When upgrading from a 100 amp service to a 200 amp service, it's important to determine if you can simply change the main breaker in the breaker panel or if you need to replace the entire panel. This decision depends on several factors, including main breaker compatibility, panel capacity and wiring, and potential upgrade requirements. Firstly, determine if the existing breaker panel is compatible with a higher rated, specifically 200 amp main breaker. Check the panel's manufacturer specifications. This information is usually found on a sticker or label inside the panel door. You can also consult with a qualified electrician to confirm compatibility. Secondly, ensure that the existing panel has sufficient capacity to accommodate the 200 amp main breaker. Check if the panel's bus bars and wiring are rated for the increased amperage. The bus bars are the metal strips inside the panel that distribute electricity to the breakers. Their amperage rating should be clearly marked. The wiring connected to the main breaker, often referred to as feeder wiring, must also be appropriately sized for 200 amps. Thirdly, some older panels may require additional upgrades or modifications before accommodating a 200 amp main breaker. This may include installing a larger ground bar or upgrading the feeder wiring. The ground bar is used to connect grounding conductors within the panel. It needs to be adequately sized to handle the increased current. The feeder wiring, which runs from the meter to the main breaker, might need to be replaced with a larger gauge wire to handle the 200 amp load. Based on these factors, here are the possible scenarios. Option 1. Change main breaker only if possible. If the existing panel is fully compatible with the 200 amp main breaker, you may be able to simply swap out the old breaker for the new one. This is usually the most cost-effective option. However, it's crucial to verify compatibility before proceeding. Option 2. Upgrade panel and main breaker. If the existing panel is not compatible with the 200 amp main breaker, you will need to replace the entire panel along with the main breaker. This is more expensive, but ensures a safe and reliable electrical system. It is also the recommended option if the existing panel is old or has any signs of damage or corrosion. Now consider the technical aspects of this upgrade. The main breaker's purpose is to protect the entire electrical system from overcurrents. When you increase the service amperage, you need a breaker that can handle the higher load without tripping prematurely, but still trip when there's a fault. When selecting a new main breaker, ensure that it has the correct interrupting rating for the electrical system. The interrupting rating is the maximum fault current that the breaker can safely interrupt. This rating is typically expressed in thousands of amps, such as 10,000 amps or 22,000 amps. The panel's bus bars are critical components that distribute electricity to the individual circuits. They must be rated for at least 200 amps to handle the increased load. If the bus bars are underrated, they can overheat and potentially cause a fire. The feeder wiring must be sized appropriately to carry the 200 amp current. The National Electrical Code, or NEC, specifies the minimum wire size based on the amperage and type of insulation. For example, copper wire with THHN insulation may require a 4/0 or American wire gauge, or AUG, wire for a 200 amp service. Aluminum wire may require a larger gauge. The ground bar must also be adequately sized to provide a safe path for fault currents to return to the source. The NEC specifies the minimum size of the grounding electrode conductor, which connects the ground bar to the grounding electrode system. A licensed electrician can perform a load calculation to determine the actual electrical demand of your home. This calculation takes into account all the appliances, lighting, and other electrical loads in your home. The load calculation will help determine if a 200 amp service is sufficient for your needs or if a larger service is required. When upgrading the electrical service, it's important to ensure that all connections are made properly and talk to the manufacturer's specifications. Loose connections can cause overheating and arcing, which can lead to a fire. The new main breaker must be securely installed in the panel and properly connected to the bus bars. The feeder wiring must be connected to the main breaker using appropriate lugs or connectors. All grounding and bonding connections must be made in accordance with the NEC requirements. Before energizing the new service, it's important to test all circuits to ensure that they are properly wired and functioning correctly. An electrician can use a multimeter to check the voltage and current on each circuit. They can also use a circuit tracer to identify any wiring errors. It is highly recommended that you consult with a licensed electrician to inspect your panel and make the appropriate recommendations based on the factors discussed above. They can determine the most suitable and safe option for your situation. An electrician will consider local electrical codes and regulations when performing the upgrade. These codes and regulations may vary depending on your location. The electrician will also obtain any necessary permits and inspections to ensure that the upgrade is done safely and legally. Upgrading an electrical service is a complex and potentially dangerous task. It's important to have the necessary knowledge, skills, and tools to perform the upgrade safely and correctly. If you are not comfortable working with electricity, it's best to hire a qualified electrician. Replacing a breaker panel involves disconnecting the power to the entire house, which requires coordination with the local utility company. The electrician will need to coordinate a power outage to safely disconnect the old panel and connect the new one. The electrician will also need to ensure that the new panel is properly grounded and bonded to the electrical system. Grounding and bonding are essential for safety and help prevent electrical shock. The electrician will inspect the grounding electrode system to ensure that it is properly installed and functioning correctly. The grounding electrode system typically consists of a ground rod or metal water pipe that is buried in the ground. The new panel will need to be labeled correctly to identify the circuits and their corresponding breakers. This will help you easily identify and turn off circuits when needed. The electrician will provide a circuit directory that lists all the circuits in the panel and their locations. The circuit directory should be kept in a safe and accessible location. After the upgrade is complete, the electrician will provide you with a certificate of inspection, which verifies that the work was done in accordance with local electrical codes and regulations. The certificate of inspection is important for insurance purposes and may be required by your local building department. When choosing an electrician, it's important to select a licensed and insured professional with experience in upgrading electrical services. Ask for references and check online reviews to ensure that you are hiring a qualified and reputable electrician. The electrician should be able to provide you with a detailed estimate of the cost of the upgrade, including the cost of materials, labor, and permits. The estimate should also include a timeline for completing the work. Be sure to discuss any concerns or questions you have with the electrician before the work begins. A clear understanding of the scope of work and the associated costs will help prevent misunderstandings and ensure a smooth upgrade process. Electrical panels are typically located in a basement, garage, or utility room. The location of the panel should be easily accessible and well lit. The panel should also be protected from moisture and physical damage. If the panel is located in a damp or humid environment, it may need to be replaced with a weatherproof panel. The panel should also be mounted securely to the wall and protected from accidental contact. Over time, electrical panels can become outdated or damaged. Signs of an aging electrical panel include frequent breaker tripping, flickering lights, and buzzing sounds. A damaged electrical panel may have corroded or loose connections, which can create a fire hazard. If you notice any of these signs, it's important to have the panel inspected by a qualified electrician. Replacing an outdated or damaged electrical panel can improve the safety and reliability of your electrical system. Upgrading to a 200 amp service can also increase the capacity of your electrical system, allowing you to add more appliances and electrical devices. This can be especially beneficial if you are planning to add a new addition to your home or install a high-demand appliance such as an electric vehicle charger. An electric vehicle charger can draw a significant amount of power, which can overload an existing 100 amp service. Upgrading to a 200 amp service will provide sufficient capacity to accommodate the charger without overloading the electrical system. Before upgrading your electrical service, it's important to consider the long-term electrical needs of your home. Will you be adding more appliances or electrical devices in the future? Do you plan to install an electric vehicle charger? By considering your future electrical needs, you can ensure that the upgraded service will meet your needs for years to come. Upgrading an electrical service is a significant investment, but it can provide numerous benefits, including increased safety, reliability, and capacity. By consulting with a qualified electrician and carefully planning the upgrade, you can ensure that the project is done safely and correctly. When planning an electrical service upgrade, consider the placement of the new panel. Ensure it meets code requirements for accessibility and clearance. The NEC specifies minimum working clearances around electrical equipment to allow for safe access and maintenance. The area around the panel should be free from obstructions such as storage boxes or furniture. The panel should also be located in a well-ventilated area to prevent overheating. When replacing a panel, consider upgrading to a surge protection device. A surge protection device can protect your electronic equipment from damage caused by power surges. Power surges can be caused by lightning strikes, utility switching, or even the operation of appliances. A surge protection device can help prevent costly damage to your electronic devices, such as computers, televisions, and appliances. Surge protection devices are typically installed in the electrical panel and can protect the entire electrical system. Consider the type of breakers used in the new panel. Arc fault circuit interrupters, or SIs, are designed to protect against electrical fires caused by arcing faults. Ground fault circuit interrupters, or GFCIs, are designed to protect against electrical shock caused by ground faults. The NEC requires SIs and GFCIs in certain locations such as bedrooms, bathrooms, and kitchens. Using these types of breakers can significantly improve the safety of your electrical system. When upgrading your electrical service, it's also a good time to inspect your home's wiring. Look for any signs of damage, such as frayed or cracked insulation. Damaged wiring can create a fire hazard. If you find any damaged wiring, it should be replaced by a qualified electrician. Replacing old or damaged wiring can improve the safety and reliability of your electrical system. Consider the type of conduit used to protect the wiring. Conduit is a metal or plastic tubing that protects the wiring from physical damage. There are different types of conduit, such as rigid metal conduit, or RMC, electrical metallic tubing, or IMT, and flexible metal conduit, or FMC. The type of conduit used depends on the application and the local electrical codes. The conduit should be properly installed and secured to the wall or ceiling. When upgrading your electrical service, it's important to ensure that all electrical boxes are properly grounded. Electrical boxes are metal or plastic enclosures that house electrical outlets, switches, and splices. Grounding the electrical boxes helps prevent electrical shock. The NEC specifies the requirements for grounding electrical boxes. The grounding conductor should be connected to the electrical box using a grounding screw or clip. When connecting wires to electrical outlets, switches, and breakers, be sure to use the correct wire connectors. Wire connectors are designed to securely join wires together. There are different types of wire connectors, such as wire nuts, crimp connectors, and push-in connectors. The type of wire connector used depends on the size and type of wire. Be sure to follow the manufacturer's instructions when using wire connectors. When working with electricity, always follow safety precautions. Turn off the power to the circuit before working on any electrical components. Use insulated tools to prevent electrical shock. Wear safety glasses to protect your eyes. If you are not comfortable working with electricity, hire a qualified electrician. Electricity can be dangerous, and it's important to take precautions to protect yourself and others. Consider the future needs of your electrical system when planning the upgrade. Will you be adding a swimming pool or hot tub? Will you be installing solar panels? These types of additions require additional electrical capacity. Planning for future electrical needs will ensure that your upgraded service will meet your needs for years to come. Upgrading your electrical service is a complex project that requires careful planning and execution. By consulting with a qualified electrician and following safety precautions, you can ensure that the project is done safely and correctly. Always remember to obtain the necessary permits and inspections before starting any electrical work. Permits and inspections ensure that the work is done in accordance with local electrical codes and regulations. Working without permits can result in fines and penalties. It is always best to follow the rules and regulations to ensure a safe and compliant electrical system. And always seek help from a qualified electrician.